Good day, dear students. Today we have Proposition 7 of Book 2, okay? Remember, Book 2 is about line, so this proposition is about this line. If a line be cut at random, then the sum of the squares on the whole and that on one of the segments is equal to twice the rectangle contained by the whole and one of the segments, plus the square on the other segment. Here we have a line, and let it be cut at random. So here we found a line, it was cut at random. Thus it is required to show that the sum of the squares on the whole, and let's pick this segment, and that on one of the segments is equal to twice the rectangle contained by the whole and one of the segments, plus the square on the other segment. Now remember, when you have a line, you necessarily have your square, because a line is 4 equal sides with right angles. You can't do anything else. It's going to be about this big, say. And when you have two lines, you necessarily have the rectangle. In this case, this and this. That'll be a rectangle. You can't do anything else. So that's why it's easy to say, oh, okay, if that's the case, we know something about this line. And how can we prove that? By drawing the squares and showing that the big chunks are equal to the little chunks. Okay? So let's do that. And I'm going to draw the same line, but now in colors. Since you guys are so artistic and you like to see things graphically, let's do it graphically. Great. This is this line cut the same way in living color. Okay? So, as they say in the book, let's draw the figure. But I'm going to do it painstakingly. I'm not just going to boom draw the figure. And I need you guys to do it the same way. Let's put the square on this line and then draw the figure. Okay, so we'll go like this. Right angles. We know we can do that. That's no problem. And cut from the greater line equal to the lesser, etc. Is that about right? Let's see if that's right when we draw another one. Right angles. About like that. Is that going to be, yeah, that's about right. Okay, and then we'll go ahead and cut this across. Más o menos. Let's do this in green as well. Okay? Now, let's draw the figure. Connect these 2 points with a diagonal. Remember, hold it and then look at the other one. That's how you get your best lines. Great, I did it. Now, from this point right here where it was cut, let's draw a line parallel to this line or this line. Choose your line. And then let's go here. From this point of intersection, let's draw a line parallel to this line. We know we can do that, remember. Given a point, not on a line, to draw a line parallel to a given line. And continue on. Great. So, here's our big chunk, here's our little chunks. Here we go. Parallelogram, diameter, or diagonal. We know that the complements, remember, these are the complements, are the ones touching, just touching the diagonal. They are equal to each other, okay? So we got this being equal to this. Let's add this to both sides. If this is equal to this, then this will be equal to this. Okay? So notice how this is used twice. I got this is equal to this. Great. And we can also say then that twice this will be equal to this plus this. Because this equals this, twice this will be equal to this plus this. And this plus this is the nomen. You remember that fancy word, nomen? I'm trying to remember how to spell that. Nomen. Maybe that's it. I'm sure that's wrong. Okay, here's our nomen. Okay, this whole thing. So twice this is equal to the nomen plus this. Okay? Great. Let's make sure, I think I might have said that wrong just a second ago, so let's make sure we get that right. If this equals this, and add this to both sides, this will equal this. But then you could say twice this will equal this plus this. And here's a nomen, so this plus this is the nomen plus this again, this square. Oh, I gotta prove that's a square. Let me do that in a second. Okay, so twice this equals the nomen plus this. Now let me prove that these two are squares, just to make sure here. If this is a square, and this is the diagonal, we know the diagonal cuts the parallelogram in half, so this is equal to this. Great. So here we have a triangle. This is equal to this because it's a square. All sides of a square are equals. Therefore, the angles at the base are equal. That's equal to that. But because these two are parallel and this is a transversal, the exterior angle, is equal to the alternate opposite and interior angle. So this equals this. But this equals this. So two things equal the same thing or equal to each other. Therefore, this triangle has angles at the base equal. Therefore, the sides are equal, etc. So the parallelogram equal. Opposite sides of a parallelogram equal. So this is a four-sided figure with each sides being equal. This is made right angle. This will be right angle because this and this equal two right angles, and this is a right angle, this will be right angle, blah, blah, blah. That's a square. Likewise, that's a square. We've done that before, that's why I did it fast. But in case you guys want to do it, you can look at it more closely, look at previous props. But you have to prove that this is a square and this is a square for the prop, okay? Let's back up. We've got twice this being equal to the nomen plus this square. Now we know it's a square. Great. But look, twice this is the rectangle contained by this, and this equals this because it's a square. Therefore, twice the rectangle contained by this and this, which by the way is the whole line and one of the segments, twice the rectangle contained by the whole line and one of the segments is equal to the nomen and the square on that segment. Great. Let's add this chunk to both sides of the equation. Okay. And now we know that twice the rectangle contained by this and this plus this chunk will be equal to the nomen plus this square and this square. We've proven that this is a square. Now look, this square is the square on this line because this is equal to this and this is equal to this. Opposite sides parallelograms are equal. Two things equal the same thing or equal to each other. So this is equal to this, whatever. And therefore you can say that this square is the square on this line. So let's emphasize that imaginatively. Let's make it the same color as this line. Okay? So, twice the rectangle contained by this and this plus the square on this is equal to the nomen plus the square on this and the square on this. Great. But the nomen plus this is this big old square. This nomen plus this is this big old square. So this big old square plus this is equal to twice the rectangle contained by this and the square on this. But this big old square is the square on this, and this square is the square on this, okay? And this is the whole line, and this is one of the segments, and this is the other segment. So now we see that twice the rectangle contained by the whole and one of the segments plus the square on the other segment is equal to the squares on the whole line, and the square on the aforementioned segment, okay? Therefore, we have shown that if there be a line and it be cut at random, twice the rectangle contained by the whole line and that on one of the segments, plus the square on the other segment, is equal to the square on the whole line plus the square on the aforementioned segment. Quod erat demonstrandum. Bye bye.